AB Calculus, section 5.2, page 4. Still working on evaluating some integrals, interpreting them as area. Let's sketch this graph. This graph will be a horizontal line at the height of 3. And we're finding the area underneath this curve line from x is 2 up to x is 8. So finding this area in here, that's a rectangle, base times height, 6 times 3, so the value of that integral is 18. If we extend this a bit further and look at an integral from a to b of some other constant, this c here is some constant, then when we sketch this graph, area underneath this curve, height, some constant c, from some a up to some b, that area in there, rectangle, whose width is b minus a and height is 6. So the value of this integral is some b minus a times that width c, or c times b minus a. Nice piece of information to know. When we look at this next one over here, this integral from -3 to 9 of 2/3 x minus 1, we'll need to sketch that graph. Measuring things off here just so we can have a pretty accurate graph. Let's see, y-intercept is -1, and slope is 2/3 up to 1, 2, 3. All right, you could just go ahead and put in these last points here. So a -3 in here is going to be -2 minus 1, which is -3. So when x is -3, y will be -3. That's right there. And then when x is 9, 2/3 of 9 is 6. 6 minus 1, 5. So all the way out here at 9, 9, 5. 2, 4, 5 is right there. Sketching this in. There's that line, and again finding area between -3 and 9 and the x-axis. We are looking at this. Now we want the area between that curve, in this case line, and the x-axis. So we're looking at these shaded portions here. We have 2 sections here, so we'll need to find the area of each one separately. Let's call this one section 1 and this one section 2. Area of section 1, 1/2 base times height. We run into trouble trying to find the base here because I don't know where that's hitting. It's not nice. Well, not as nice as if it hit at 1 or 2. And we can find that value by doing 2/3 x minus 1 is equal to 0. Pull that 1 over. 2/3 x equals 1. X is 3/2. So that's happening at 1.5 right here. Sorry, you couldn't see that. I'm sorry. Here it is now. All right, so this base then is 3 to get up to the y-axis, and then 1.5 past that, so 4.5 or 9/2 times a height of 3. This gives us 27/4, and if we flip that to a mixed number, that's 6 3/4. Area of that second region is, again, a triangle, 1/2 base times height. Base from 1.5 up to 9, that's 7.5 or 15/2 times height 5. That'll give us 75/4, which is 18 3/4. If we add these together, we will get 24 from the 6 and the 18. 3/4 and 3/4 is 1.5. So we end up with 25.5. All right, now there is a wonderful built-in program on your calculator called fnInt, and this fnInt evaluates integrals by summing the areas of an infinite number of rectangles. So fnInt can evaluate all of these integrals by summing an infinite number of rectangles. You will more than likely find this under alpha, F2, and then the fourth choice. All right, alpha, F2, fourth choice down is fnInt. Oh, and it looks like that. So if we look back to the very first problem that we did, the integral was -1 to 3 of x plus 1 dx, and 8, and that matches the work that we got. Please pause the video and go ahead and use this program on your calculator, the fnInt, and check the answers to number 3, number 4, and number 5. Seriously, pause the program, pause the video, and go check these. Thank you, welcome back. Assuming you checked all of these, you will see that there's a discrepancy on this 5th example. The calculator did not give us 25.5. The calculator actually gave us 12. 25.5 is the wrong answer. 12 is the correct answer for the value of this integral. 12 is the correct answer for the value of that integral. And if we look at the two pieces we got, 18 3/4 and a 6 3/4, if we subtract those two, you will get an answer of 12. What happens when we're using area to evaluate an integral is that sections underneath the x-axis are accepted to be negative. Ooh, so stuff underneath the x-axis, area underneath the x-axis now is accepted to be a negative area. All right, if we look at this next one, we'll find the area enclosed by f of x equals x squared minus 4x plus 3. We do want to sketch this graph. First, we can look and see that this will factor into an x minus 3 times an x minus 1, which sets up for us the zeros of this function. All right, so we have zeros at 1 and at 3. Vertex has to be halfway in between, so at x equals 2, plug a 2 in here. We'll have a -1 times a 1, which is -1. There's that vertex. At x is 0, this function is 3, and we're doing area from 0 to 5. So on the other side, right out here at 4, we'll also have a height of 3, and at 5, that gives us 5 in here, 2 times a 4 is 8. And that'll be right there. When we sketch this curve in, we see this parabola. And again, we want area underneath this curve, or between this curve, I'm sorry, and the x-axis, between this curve and the x-axis, between x is 0 and x is 5. So these sections that we want, this one, that one, and this one. If we are to evaluate purely the integral from 0 to 5 of x squared minus a 4x plus 3, that will allow for area or stuff underneath the x-axis to be negative. But since we want the total area enclosed by this function, we want all those sections to be positive. We are going to have to break this up to 3 separate integrals, and we'll have to do the integral from 0 to 1 of x squared minus 4x plus 3 dx. We also have to do that integral from 1 to 3 . And finally, the last section, the integral from 3 to 5 of x squared minus a 4x plus 3 dx. When you zap these integrals in your calculator using that fnInt, you will get 4/3 out of this one, a -4/3 out of this one, and a +20/3 out of this one. And we have this negative piece here. Well, we don't want that negative piece. We want everything to be positive, so we're going to have to subtract that negative value, because subtracting a negative value will turn it positive. So this should be minus up here. And then we're going to add on that other positive area. 4/3 minus a -4/3, that's 8/3, plus 20/3 is 28/3. There's the total area enclosed by that function and the x-axis. If we wanted just this integral, so if we said evaluate the integral, then we do want to keep this one as negative, and we would end up with 20/3. Thank you. Please join me for page 5.